much interested in is our drinking water. It is a area of the general environment that we all live in that we don't always think about. And there are unfortunate new news about something called forever chemicals that Aqua PA has, in the past several years, has worked hard to limit in our drinking water. So this is something that I think we all should be aware of. And so I'm going to introduce Dave Ruste. He is a director of water quality and environmental compliance at Aqua PA. Where is your office?
Down in Bryn Mawr.
Bryn Mawr, okay. And he acts as a liaison between the utility compliance and operations departments in the at the actual station. He has a bachelor's in environmental biology from Kutztown University, and he's been at Aqua PA for 10 years. Thank you, David.
Thank you. Appreciate it. All right. Welcome, everybody. Thank you, Dan, and everybody else for having me today. Nice small group, so got a lot to talk about. I guess just to give a little bit of background on myself, Director of Water Quality and Compliance, and that covers the entire state of Aqua, Pennsylvania, our facilities down here in Southeast, as well as other areas around the state. A little bit of my background, my expertise is drinking water regulations, incidentally, at my time at Kutztown University, I was also on the Environmental Advisory Commission as student liaison to the board there. So it's kind of nice to be back in a different setting many years later to tell people about the important topics that we're going to discuss. So what are we going to discuss tonight? As Dan mentioned, forever chemicals, PFAS, it's a very hot topic. It's on everybody's mind. But more generally, I want to also talk about the sources of water that are served here, how we protect those sources of water, and how you can, not only individually, but also as a community, as an EAC, protect those sources of water. Talk a little bit about lead. And then, if you have any burning questions as we go through relating to something, feel free to kind of stop and ask. Otherwise, if you want to hold questions to the end, we can just take it from there. So, all right. Yep.
Can you get the volume up just a little?
Speak a little bit more into it. Is that better? Okay. So, of course. So a little bit about Aqua America is that we've got a long history. It started right down here in Southeast PA. Formerly the Springfield Water Company, and then that formed into Philadelphia Suburban Water Company, and now Aqua Pennsylvania. So there's a lot of experience here, not only in this area, but also in the industry for water and wastewater. And you'll often see us in the streets doing projects and main replacements and other aspects because we continue to try to invest in our community, invest in our infrastructure to make sure that we can continue to provide drinking water and wastewater services. So a little bit of statistics on the side there. In particular for Pennsylvania specifically, there's a lot of facilities, about 12 different water treatment plants that take surface water, which we'll talk about a little bit, and about 200 or so groundwater wells throughout Pennsylvania. So a lot of facilities across a large geographic area. Most importantly here is, as I'll touch on later, I'm an Aqua customer. I live in Abington Township. My family and friends are Aqua customers. We are active in the community, which I'll show a little bit about. We're customers as well. So, you can't import water from somewhere else. It's a very local business, and I think that also speaks to the fact that we're local down the street with our corporate office, and that we're active members and employees in the communities that we serve. So, starting with source water protection, on the right, this is a picture of our Pickering Reservoir. And the sources of drinking water, just generally, we normally think of surface water sources like streams, lakes, creeks, rivers, stuff like that. And then pooling water out of the ground for wells, for example, it's groundwater sources. So for Radnor, for example, primarily this is fed from a surface water treatment plant. Because surface water is impacted by the environment, we have to make sure that we protect those sources. So I am sure that we've all seen a graphic like this before in the past. I really like this graphic because it really does a good job, first, of kind of conveying that everybody lives downstream at some point. It really does a good job at showing, first, that there are direct or point sources of contamination in the watershed or in the surface water sources, but then there's also indirect or non-point sources of contamination. And what this really conveys, in my opinion, is that while there are multiple points on this graphic of potential contamination, it really is a communal-based effort where if we want to protect this source of drinking water, then all of these aspects play together in the quality of the water that is in the surface water sources. So whether individually or whether as a community, all of these steps that we can do to protect the surface water sources ultimately protects the drinking water and helps the environment at the same time. So what are those things? Well, it's a lot because every source of drinking water, river, stream, lake, is fed in a watershed. So for example, here are some of our focus watersheds in southeast Pennsylvania. On the right-hand side is Neshaminy Creek. And if you're familiar with the area, kind of starting up in, out by Chalfont and going through Tyler Park and then down through a number of different areas. And it's very large, and there's lots of different contributing tributaries to that watershed. Whereas on the bottom middle, you've got, in order from left to right, you've got Chester, Ridley, and Crum Creeks. And then on the left-hand side, the east branch of the Chester Creek. So the reason I point these out is because for Aqua, these are watersheds that are priorities because they are drinking water sources. So it's not just the immediate river or creek that we're pulling out of, it's everywhere upstream. And it's all those potential sources of contamination, whether it's residential, industrial, commercial, what have you, direct discharges or indirect sources. How can we protect that? And that's what I'd like to speak about today with everybody here because I think this is all near and dear to our hearts. So here's a little bit about what we do to protect watersheds and then protect source water, which then protects the drinking water that is provided to our customers. We have dedicated staff that are out in the watersheds, either observing the riparian buffers or observing the quantity of water or observing the sources of potential contamination upstream. They could be taking samples for water quality or trying to mitigate nutrient pollution from certain, maybe agricultural or other sort of land uses. We have multiple reservoirs that are providing drinking water to our surface water treatment plants, so managing those reservoirs, which often comes with managing of a dam and making sure that it's not only properly constructed and safe for the communities that we serve, but also maintained in a way that is protecting water quality as well. But most importantly, we are involved with multiple different partnerships across many different watersheds. Just a few examples listed here. For example, our manager of corporate giving is on the board for the Partnership for the Delaware Estuary. And another person in our legal department is on the Schuylkill Action Network. And Aqua generally is a member of the Delaware Valley Early Warning System, which might not be widely known for the consumers, but on the utility aspect, this system provides a centralized alert system for activities that occur in the watershed. Say if there's a fire or a spill or something like that, it's a coordinated effort through multiple agencies to alert water suppliers, other things like that, that something's going on, and provide early notification to prevent any sort of problems from happening with drinking water. And this ties into the planning and protection of all of these sources, because not only do you have to make sure it doesn't get contaminated, but then always improve the state of the watershed as well. And we do that in multiple ways, not only engaging with these watershed partners, but also through grant programs, through volunteer efforts, and that includes anything from weeding garlic mustard, as was done yesterday, but also trash cleanup, tree plantings, other sort of aspects like that, and I'll touch on that here as well. So protecting the environment really is source water protection and therefore protection of drinking water. And these are just some of the aspects that we can do not only individually but also as a community to protect drinking water. I'm not going to go through all of these, they're all on the slides. I'm just going to point out a few that are kind of close to me. I think one of the ones that we observe over the winter is de-icing salts and road salts. And they tend to, when the snow melts, wash off into the storm sewer and then go into the local creek. And so we will often see an increase in conductivity in the sources of water that we see in the streams or creeks that we pull out of as a result of that road salt. So one of the most important messaging that I can convey is use road salts. It's a safety issue. It's important. I agree with that. But use it judiciously. You've seen some roads this past winter and they were white. So just something to consider. One other aspect is relevant to the everybody is downstream is the toilet is not a trash can. And I know that messaging was very frequent over COVID time. Don't flush things, properly dispose of household chemicals, medicines, utilize the hazardous waste cleanup efforts from your township. Do not flush them down the sewer. It's not the spot for it. Storm drains and stormwater management, it's all very important too because that could wash out an influx of high amount of rainwater, could wash out certain watershed areas and create a lot of not only erosion, but a lot of sedimentation downstream of where that is, which could impact the amount of turbidity in the water, stir stuff up, make chemical cost and therefore treatment much more complicated. In a former life, I was very involved with native plants and other aspects. So how can native plants and riparian buffers improve drinking water quality? Well, quite simply, they're supposed to be here. They thrive in the environment that is Southeast PA or Pennsylvania, relatively speaking, and they don't require the inputs that other ornamental or types of plants may have in the landscape. So it's a very simple, good for us, good for the environment type of approach. So this is, I like this sign on the right here for Green Lane Reservoir, just as a messaging aspect to everybody that visits for a walk on the trails or recreational purposes, that this is a drinking water reservoir. And it's miles away from any sort of treatment plant, but it's important there, just as it's important close to our treatment plants, that source water is protected. And similarly, fats, oils, and grease flushing down the drain. This picture on the bottom middle is a result of what can happen when those fats, oils, and greases congeal in a sewer system and cause a blockage and then eventual contamination to the environment. But mostly providing and protecting drinking water, use water-efficient appliances. Don't waste water. If you want to install a rain barrel or a few to collect that rainwater and use it for your plants, conservation of water is a good thing too. So I would encourage that as well. As far as community impact, this is a summary of the 2024 volunteer efforts and other sort of Earth Day events that we had. We are still tabulating the information for this past Earth Day, which was about a week ago now. So as you can see, a lot of volunteer hours, and this is over the entire footprint of Aqua America. So it's not just down here in Pennsylvania, it's all of the Aqua states participating to protect the environment. And I just love seeing 41,000 trees and wildflowers planted across all the different areas. A little bit of a way to give back to the community. Okay, now we get into the fun stuff. So I'll keep it at a high level here. So this is kind of my expertise a little bit, but I think to keep it simple here, drinking water regulations are first come from EPA, the Federal Environmental Protection Agency. And EPA's job just generally is to investigate the science and the health impacts and where certain contaminants may be. They decide to make rules on that, and that gets translated down to all of the states. Then for Pennsylvania, they have to follow EPA standards, but they can also make tweaks or adjustments to be more stringent, but they can't be less stringent than federal standards. And similarly on the wastewater side as well with the Clean Water Act. So I believe we just went past our 50th anniversary of the Safe Drinking Water Act just a few months ago. So it was 1974 on the federal basis. And then Clean Water Act, I think, was 1970 or so. But either way, the federal guidance gives us, as the states, what rules we need to follow and implement. So I like this graphic as well because it kind of goes through at a high level the steps that are involved in surface water treatment. So treating that water from a lake or a stream or creek. And this is generally the process that it will follow. Complicated, there's a lot of stuff up there. Generally, I'm going to emphasize the disinfection aspect. I think, Dan, you mentioned speaking about bacteria and other things like that. So first, to keep it simple, is we take the water in and we remove any solid material from the water. Then we filter it out to make sure everything is removed, and then we disinfect it. So let's start there. So we often hear, I guess, concerns from customers that the water smells like bleach. Yes, it does. So I think when I was in college and I took a microbiology course, there was a lot of emphasis on the public health impacts of the microbiological revolution in the early 1900s, the discovery of penicillin and germ theory and a bunch of other cool things. So I might be a little bit biased, but if you look up chlorination of drinking water supplies, it is a very substantial public health benefit. And it's not just a public health benefit anymore, it is a requirement in multiple ways. So there's fancy language up here with a number of rules. I'll make it very simple. In about the 1990s or so, the surface water treatment rules said you have to disinfect surface water. You have to. Other stuff in there too. The groundwater rule in about 2006 said you have to disinfect groundwater. And then there was a requirement, a previous rule that said you have to sample for bacteria through all the pipes in the street, the distribution system that distributes that water to the customers. And then it got revised again in about 2015 with the revised total coliform rule. So we're talking in this progression, disinfection being required at the treatment plants, and then with the revised total coliform rule, when you are disinfecting, you now have to go out and sample for bacteria throughout the distribution system to make sure it's still properly disinfected for the customers. And then Pennsylvania in about 2018 came and added another layer and said, not only do you have to do that stuff, but you also need to make sure that you have a minimum chlorine residual at representative points throughout the distribution system. So when I hear somebody mention the water smells like bleach, I say, yes, we're required to do that. And that is a good thing for both you and I. So a little bit about lead. which also has been prominent in the media, in the news, in the concern amongst customers and consumers. And I like this graphic because when we often hear about lead in the water, I think there's a perception that the water was being supplied with lead in it. And that is 99% of the time not true. The lead is in the plumbing within the houses, either within the solder or within the meters or within the faucets or any other number of things attached to them. What this graphic shows is that when we talk about lead, we're often thinking about the service line connecting that customer to the water main in the street. There's two sides of that service line, which is the customer side, which is owned and maintained by the customer, and then there's the company side, which is owned and maintained by the company. So when we have lead as a service line, which side is it on is important to figure out. These are some of the materials that can compose service lines: copper, PVC, galvanized steel, lead. Going a little bit further with lead, kind of looks silvery, looks like any other pipe, but it's easily scratchable. You take a key and scratch it and rub some off. A magnet won't stick to it. It often has a characteristic bulb on some of the areas close to where a joint may be. But most importantly, neither you nor I want lead to exist as a service line or a piece of plumbing material. And there is a regulatory requirement now coming soon, which is that we must identify all of those service line materials for every customer. And this is across the nation, to identify all of those service line materials, not only on the company side, but also on the customer side, to determine, is it lead or not lead? And then within 10 years, so 2037 is going to be the final year, all the lead has to be removed. So if I'm sitting in your shoes, I'm thinking, how can I help? How can I figure this out? What does this mean for me? The graphic on the right here actually is for Radnor Township. It's hidden behind those dots there. But what this graphic shows is on the right-hand side, the customer side, and on the left-hand side of the little dot there is the aqua side. So if you go to the website down in the bottom left, not only does that website have information about lead, about health impacts, about how you can be involved, but you can also get to this service line material viewer to check your address, check your neighborhood. Is my service line on my, the customer side, my service line, is that identified? What is my service line made of? And then you can reach out to Aqua if you have a lead service line, or if you think you do, to see if we can help. And there's a program to help, which is this program called Act 120. Basically, not only does it allow Aqua to have a contractor replace the lead service line, but it is at no cost to the consumer. So it alleviates the health impact of having lead as a service line material. It eliminates the cost impact. So it's really getting the word out that this program exists to encourage this process. And as we make our way through townships and neighborhoods, continuing to put this message out there to make sure that we're protecting the most customers and getting ahead of this program as soon as possible. Yep.
I see my house on this map. I'm on North Bellevue, which is in the upper left. There's kind of a diagonal street above Lancaster Avenue, and there's a series of houses, and we're the fifth house coming from either end of the street, and that looks like the fifth dot there that's got half tan circle. So it says galvanized requiring replacement, and this is on the customer side.
Sure.
So you cannot have galvanized pipe in your house as a main service line?
The simple answer is we are treating galvanized the same as lead. The simple answer. The more complicated answer is the rules say if it was galvanized but downstream of lead at some point in the past, but that's very hard to determine.
Right.
So we're just treating galvanized as the same. Now, from a risk perspective, it's not the same because, like we said, we can't be sure it was downstream of lead.
Right.
And let me be clear, even still, lead, galvanized or not, there are treatments in place, which I kind of alluded to here. There are treatments in place, corrosion control treatments, kind of as we say, to make sure that the water is stabilized so that even if you have lead materials in your house, or galvanized for that matter, that it's not leaching lead at a level that would be unsafe, or really at all is the goal, right? So adjusting the pH to make it stable, providing what's called a corrosion inhibitor, or that's what they kind of allude to here, that's going to provide a protective coating on the piping to prevent that, that lead or copper from leaching out into the customer's water. So good observation, Dan, and it's already been identified. That's great. And at some point in the near future, as we make our way through, I'm sure you'll be getting a call or call into us and see if we can get that swapped out.
So if it's white, it's unknown, so that means you're sure about everything that's blue.
There are multiple data. So the question was, if it's white, it's unknown, and that means we're sure about all of the other data points. So it's a good question. I'll just put it this way, there's very complicated layers of validation. We are dealing with very, very large numbers, a couple 100,000 services, both, times two, because you got customer side and aqua side. So a very high degree of certainty if we've placed it on that map. Have there been errors? Of course. And that's why getting the word out and getting people to check and verify is very important. So the goal is to, as I said, to get these things, get this messaging out there, get the Act 120 program out there, and make sure that we can get it on this list and start to remove these things as we move through over the next number of years. Okay. So PFAS, forever chemicals, I think have been in the news probably from about 2016 or so, but have really hit some momentum in recent years. They're manufactured chemicals. They are man-made. They are not naturally occurring. They've been used for decades, I think 1950s or so, in many applications, nonstick pans, Teflon coating, other things like that. Many consumer products. They do not break down easily in the environment. Most commonly, you'll see PFOS and PFOA with fancy chemistry chains of carbon and other things on there. But they are persistent in the environment. And part of the problem also is that they can accumulate in living organisms. So they may accumulate to some organic matter, and then a fish eats that, and a bigger fish eats that, and it can accumulate through the food web. They can make it into the environment, and then there are multiple routes of human exposure. So the graphic on the right is from U.S. Centers for Disease Control and Prevention, CDC, and it shows that about 80% of exposure is from consumer products, other environmental factors, things like that listed below. And then the remaining 20% of exposure to PFAS is drinking water, where PFAS is present in the drinking water. Multiple different health impacts, not my area of expertise. However, I think each different type of PFAS, of which there are tens of thousands, they're really investigating for different types of health impacts, but generally these are some of the impacts that have been noted in the literature. So how do they get in the environment? Well, they've been in consumer products. So if any of that made it down the drain to the wastewater plant, made it into the creek, we're all downstream once again, then it could be from a discharge, it could be from a spill, it could be from the firefighting foam from a fire event that just required that foam to be used, right? When we're none the wiser to the health impacts or the persistence in the environment all of 10 years ago, or other waste streams. And they're able to migrate between surface water and the soil down to the groundwater and back up again. So to put this in perspective, we're talking minute concentrations of PFAS. And I like the graphic here. I think I've heard a couple other similar analogies, like a blade of grass in the state of Maryland or something to that effect. But I like this one, right? It's one drop of water, one single drop of water in 20 Olympic-sized swimming pools. And that makes me ask the question, wow, how do we measure down that low with analytical equipment? That's impressive. And it is very much that low. And as I mentioned, it is widespread in the environment, very widespread. So this graphic is from a United States Geological Survey paper that they published, I think, October of last year in 2024, that they used a bunch of complicated modeling to estimate the probability of PFAS chemicals in groundwater at the depth of public drinking water supplies. So what does this mean? Where you see orange and where you see red, there is a very high probability of PFAS in areas that are potentially used for drinking water supply. And there's hotspots across the United States. Primarily, I think identified in the paper was Florida, New Jersey, aspects of New York as well, Pennsylvania also, and then certain aspects of California. So it is very common. Yeah, New England states, exactly, yep. Massachusetts looks pretty red up there. So it's there, and I think most importantly,
They have more than a drop.
it seems that way. But I think most importantly is we didn't put this here. The consumers didn't put this here, right? While there are consumer products that are available and have come to us, and that's potential exposure route, that's fair. But this level of contamination, it got there from other means. Like there's something else going on here, right? So how do we clean up all this stuff? How do we provide and protect drinking water from these chemicals that are seemingly so widespread, and also that we didn't put there in the first place, right? So I don't want to talk about this too much other than to say the regulations are a guiding force in drinking water for what needs to be done. And they're based off health exposure, health risks, the treatment abilities, all these things. So for years, there was not much in the way of guidance on what levels are considered safe. And over the past decade or so, as the ability to measure got better and better and better, the understanding of the science also got better and better and better as there was more evaluation of how widespread, but also the impacts of health on humans. So what this breaks down to is Pennsylvania went through the effort with toxicologists and all these other studies to develop levels. Their numbers, 14 parts per trillion and 18 parts per trillion. And then a couple years later, actually, I guess a year and some later, EPA came up with 4, which is different, but it's a number. And over the years, we've seen a number of different states come up with their own numbers as well. So now we have a guiding force that we can use to plan and protect and move forward. So, what's that? 4 part per trillion. So 4 drops of water in 20 Olympic-sized swimming pools. where that graphic was. So I'm not going to go into this other than to say there's a few ways to treat for PFAS and remove it from drinking water. Granular activated carbon, which generally means bigger vessels, and anion exchange resin, which generally means smaller vessels, but it's a different, newer technology. Here's a bit of a timeline on what Aqua has done. And first started testing for PFAS in 2016 when the target level was 70 parts per trillion. And then that number changed a few years later. We installed our first treatment system in 2017, and then another in 2017, and then another in 2019. Just keep going. And then in the absence of regulatory guidance, Aqua developed their own internal company standards by which we would commit to designing and installing treatment in 2020. As of 2024, we met those levels, those 14, 18 levels for Pennsylvania's MCL, and then going forward with EPA's rule, which we'll talk about in a second, plans underway for a long time now to commit to meeting the federal PFAS regulations as well. So this is just an example picture of what a treatment system with granular activated carbon looks like at a groundwater facility. Very large vessels, there's a lot of carbon in those vessels, and the water ends up flowing through one and out the other, and at the end of the day, non-detect. And the non-detect of today is much better than the non-detect of 10 years ago because we can measure much, much, much lower than we could. What's that?
All water flowing through that?
For the treatment facilities where the treatment is installed, yes, the water is flowing through that.
So the Pickering Creek facility is using carbon?
So this is, the picture here is a groundwater facility. Surface water treatment is much more complicated for PFAS treatment, but we are doing treatments at at many of our surface water treatment plants in Southeast Pennsylvania using a different form of carbon that actually does remove the PFAS. So as it stands today, we are looking to meet the EPA's PFAS limits using that technique.
4 ppt.
Correct.
4 parts per trillion.
Most importantly, we have been doing testing and demonstrations to verify other technologies that we can use for treating PFAS. And here's just a couple pictures of some testing that we did, year-long pilot testing with complicated reports and sample collection to be able to use different types of media, different types of technology, and demonstrate that to Pennsylvania DEP. So with this slide, I just want to convey maybe 2 simple statements, which is getting treatment installed for a drinking water facility is complicated, as it should be. The rate of being able to demonstrate a technology works in drinking water has to be verified and then constructed and approved, takes time. So for granular activated carbon, for example, it was relatively quick, only about 2 years or so before we were able to get things online. Whereas with the other technology, ion exchange, although we demonstrated it, it took about 5 years to demonstrate, go through all the testing, and then get everything constructed. But fortunately, because we did all that hard work years ago, I mean, look at these dates, 2018, 2016, we've been at this for a while, we have successes like this. So this is last year. 3 different treatment facilities, 2024 as well as 2023. We installed another system last year, but we have now 3 anion exchange treatment systems online that we did the work years ago to make sure that the technology was verified and usable so that we can fit it in smaller footprints where we may be constrained in a community, a small parcel size, or other unique circumstances that call for this. So this was many years in the making, and it's very complicated, but also very expensive. So happy to celebrate these, and by nature of doing this, we're able to protect multiple communities and remove the PFAS. Yes? Radnor does not have any of these treatment systems because this Radnor Township is fed from the Pickering complex, which is using a different type of carbon as a treatment system for PFAS removal. Correct. Yes.
I know that the Hatboro Borough Township are near Air Force Base where PFAS-containing fire retardants were used often for treating fires. And I think, unfortunately, those municipalities have the highest ground level of PFAS as a result of.
So that's why those particular places were chosen?
Well,
These-
yeah, Dave, I presume these, at least the Horsham wells 6 and 8 were chosen because you had a big task there to lower the PFAS level because of the Air Force contamination, right?
So they are, you're correct, they are nearby the Horsham Naval Air Force Base. For example, the Horsham wells 6 and 8 on the right-hand side there, that was chosen for this treatment because the levels were elevated, yes. However, they were below the Pennsylvania levels. So we've started on these projects years ago. For example, Hatboro 6 and 8, Horsham Wells 6 and 8, we started on this project back in 2020 or so. Actually, probably about 2019 or so. And it took a lot of time. And at the time, we, throughout this process, met the company standards and then met the Pennsylvania standards. So that's the benefit of having this strong regulatory guidance now, is that we've already installed treatments. We've prioritized appropriately to make sure that we were addressing the communities that needed it most and moving quickly to get it done. But then also staying ahead of this so that we started working on this years before Pennsylvania came out with their rules.
Yeah.
And then we're able to meet those rules even though we finished installing this at the end of the year, right? So we were meeting it the entire year and then put it on right at the end, which was good.
Yeah.
And now will be non-detect. And then the other ones are, Perkiomen Woods is more Collegeville area. North Hills is Abington Township as well. But North Hills on the left, for example, that is the facility that took about 5 years or so to get from start to finish. And during that time, the well was shut down. So it's complicated from a supply perspective, making sure that there's enough water, but also making sure that we can do that and still, bring water in from other areas. And while we're finishing the design and construction of a treatment system so that when we turn it back on, it's non-detect for PFAS. So complicated regulatory language here. The answer is basically the rule went into effect in 2024, and we have 5 years. The nation has 5 years to collect all the data, design facilities, and figure out all the complicated aspects of running these treatment systems and meet the levels of 4 parts per trillion by 2029. One sort of, underdog in this story that really supported Aqua's efforts from the beginning is the efforts of our laboratory. And so, as I mentioned already, as the understanding about PFAS and the technology for testing for PFAS got better and better, the laboratory at our Bryn Mawr facility as well was keeping on pace with the science and the methodologies and all the other testing associated with it. And that type of investment has really bared fruit because it allows us to be ahead of the curve with making sure that we can measure down low enough, collect enough data to demonstrate to Pennsylvania DEP or EPA that we are removing the PFAS and prioritizing effectively to make sure that we're addressing it. And it tests for a variety of compounds, not just PFAS, in multiple different certification states. So they're able to do samples across multiple different states. And I believe they are still the only utility-owned laboratory in Pennsylvania that is able to test for PFAS. There are not many facilities that even do PFAS testing still. So that could be a major bottleneck for other water providers. And this is just a little picture of what is one of the steps in the process. It's sample extraction. So you take this 250 mil and you distill it down to less than 1 mil, and it's a tiny little volume. And then you run some other fancy chemistry stuff through it, and you're able to get a result. But it's a lot of samples. 20,000 PFAS samples run to date. I believe it was 4,000 or so last year alone. So we're keeping the chemists busy. It's a large effort, but for a good cause. But mostly looking into the future, as we continue down this path of aggressively moving with demonstrated technologies, installing treatment systems across the footprint where it's necessary to comply with the federal rules. Of course, there are challenges. There's the entire nation that was on that USGS graph or picture that also has PFAS. They are looking for the supplies, the steel tanks, the media, the carbon to do it. And so as we look into supply chain demands, conditioning ourselves to be at the table to make sure that we can get ahead of the curve before the rest of the country is kind of buying over limited resources. So things like tariffs or price competition or supply chain challenges or shippings from overseas all are something that we're paying attention to navigate complicated supply chain efforts as we're trying to protect public health by installing PFAS treatment systems.
Can the resins be reused, or is it a one-shot deal?
So I guess the question was, can the resins, the anion exchange resins, be reused? That is a very hot topic right now. I've been at many conferences where very smart PhD people are talking about different methods of doing it. Long story short is right now it's being researched heavily because that would be a very sustainable path forward. As it stands right now, as far as what's acceptable according to PADEP and EPA, single use and then disposed of. So maybe at some point in the future.
And the same with activated carbon. You can't reuse it, right?
Activated carbon can be thermally regenerated.
Oh.
It can be basically cooked in a kiln above a certain temperature to burn off any contaminants that are contained within it. You'll lose some material in the process, but then that material can be reused. Generally, more so reused for industrial purposes at that point, but it can also be used, and it has been approved for use in drinking water supplies afterwards. So, yes?
So, bottom line, what should we be doing to, ensure that our water is safe? I mean, water filtration, reverse osmosis, because when I look at the environmental working group for my zip code, which is right here, it says that we have something like 41 total contaminants detected and 19 exceed the limits.
When you're looking at the Environmental Working Group website, the levels that they choose to compare are standards that they created. So in the industry, we have to trust what the EPA provided as levels that are safe for supply.
Okay, well then, back to my initial question, what should we be doing as far as filtering our drinking water to get out whatever contaminants are still getting in there?
So like I mentioned, this water, the water in Radnor Township is primarily supplied from our Pickering complex up in Valley Forge area. We have implemented treatment up there to remove PFAS contaminants. my goal for you and for all of our customers is I don't want you to have to do anything to your water other than maybe remove the chlorine if you don't prefer the taste with a pitcher filter or something like that.
Well, that's the end goal, but between now and then, what do you recommend?
Agreed, and that's exactly what I'm saying is as it stands, we have implemented treatment at the water that's being supplied to this area, so it is removing those PFAS compounds.
What about fluoride? What's the story on fluoride now?
So the question is about fluoride. So I guess generally at least, how do I say it? For this township, for Radnor, there is not fluoride in the water.
There's what?
There is not fluoride in the water, at least not fluoride that we add. There's some at certain pockets throughout the country, there's naturally occurring fluoride, but none that we're deliberately adding. In general, fluoride addition is a requirement for a health department or for a township, or comes along from deed of sale or something like that we must continue to fluoridate the water. As far as the future of fluoridation, uncertain at this moment. I know that's a hot topic out there in the media right now. Waiting to see what the direction on that is.
So you said fluoride is not being put in the water?
Not in Radnor Township. So there's only a few areas for Aqua Pennsylvania that do add fluoride. For example, Westchester or Media or a couple other spots. And in those areas, it's typically a condition of or a requirement that we continue to do so. But for Radnor Township, we do not add the fluoride for the sources that are being provided here.
Is there a requirement in Media and Chester?
I'm just giving, I'm sorry. In general, that's kind of the background of why there is fluoride added. As far as reasons for that, I cannot say.
Okay, so there's local conditions that
Generally, yes.
by regulation mandate fluoridation, or is then put to a township council to decide to have fluoride?
It's a local control.
Local decision.
It's a local decision, and
Okay.
I apologize. I used Media and Westchester as an example of areas that are fluoridated, but I cannot speak to the reason why or the local reasoning on why that was. But it's not, for example, adding fluoride is not a requirement from the Safe Drinking Water Act or a requirement from Pennsylvania DEP or from EPA for that matter.
Okay. Any other questions? Do you partner also with environmental nonprofit groups like Delaware River Keepers, who are just like you, very concerned with contamination of our water supply? In terms of public outreach, or even assistance in sampling, have you ever worked, because you had those 3 or 4 organizations on your early slides, but I didn't recognize any of them, and likely not nonprofits. Do you work at all with nonprofits?
So I believe, except for the Delaware Valley Early Warning System, the CRC, the Chester Ridley Crum Watershed Association, Delaware Estuary, and a number of other, Schuylkill Action Network are a few that come to mind. There are multiple others. I think Neshaminy Water Creek Association. They're all, to the best of my knowledge, nonprofits, local organizations, nonprofits that are either volunteer or otherwise community efforts to protect the watershed. And so that's where, for example, our grant programs or volunteer efforts will come in to synergize the benefits of what a watershed association is already interested in doing. Great, we want to protect that watershed too. We want to protect the environment. You guys are interested, we're interested, let's team up and do some stuff. So those were just a few examples in the earlier slides, but there are many, many more that the staff that we have on the environmental side get involved with to collaborate and maximize the benefit for the consumer and the environment.
Well, the EAC is available to to help you if you're looking for community volunteers or any way.
Appreciate it.
Yep.
That's great. Okay. Yes.
Microplastics? Microplastics.
Interesting question. So there's actually a presentation earlier today I wasn't able to attend about microplastics. There's been a lot of interest in microplastics. And I believe a gentleman spoke here not that long ago about the topic of microplastics. From my admittedly limited knowledge on the topic, there's a couple of areas of research that still need further development, such as the health impacts, although there's stories of, this much plastic is in our brain for exactly. What does that mean other than shock value? I'm not sure. But in the presentation earlier today, it had a couple questions that they were going to evaluate, which was kind of the development of the science about those health impacts, but also in order to develop standards or
Do you measure?
that was my point, is the ability to measure has not been standardized either. So everything we do in drinking water, which was kind of alluded to on my slide about the regulatory oversight, every testing mechanism that we use has to be approved by EPA because it's a standardized way that we all agree on, the water and wastewater industry. This is how it's tested because it's been shown to be reliable for detecting to this level and all that fancy stuff, right?
So it's on the radar.
It's on the radar, but there are no standardized methods, to my knowledge, yet on what that means. So combined, uncertainty on how to test and quantify with the health impacts, it's a hot topic right now. We're paying attention to it. I know others are paying more attention than I within Aqua right now, but it is on our radar to see what that means. So, but I think it's the main takeaway there in my mind, it comes back to the earlier slides. Protection from the source water protection, plastics in the environment, removing it from the storm drains, removing it from the cleanup efforts, keeping the plastic out of the environment, because once again,
We have to buy plastic bottles of water. Doesn't make any sense.
agreed. So to the extent that it's empowering for us to say that, hey, we do have a control, we can contribute to the environmental protection of our watershed, for example, by something as simple as picking up trash and making sure it's properly placed where it needs to be. That's pretty strong. So,
When we're using garbage disposal, I don't know what the rules are as to what you can, I never even thought of it, the crap that you grind up.
Sure.
goes in why do they even allow them?
I will speak personally on that matter. I have one at my house. I do not use it. I never use it. There's nothing that goes down my faucet or my sink in my kitchen that I cannot just as easily put in the garbage. I don't know why they're allowed. There's very strong feelings on the wastewater side about that. Personally, I would discourage them, but that is a non-Aqua sanctioned opinion. But it's a good question. So, anything else?
Well, this activated carbon treatment, hopefully it will not only extract PFAS, but also, volatile organic chemicals, for example, if they're, polar enough. But I'm also thinking about some plastics, like vinyl plastic particles. The hope is that you're already doing something about some plastics with your activated carbon treatment. So, thank you.
You are correct, Dan. Carbon can remove other things, and appreciate that.
Any other questions? Okay. Thank you so much for coming.
Feel pretty good about Radnor Township water,
I agree, yes.
relatively speaking.
I agree, yes. And we have excellent customer service in the water quality group that I deal with that you can call, because sometimes you just have a question. Sometimes something, you want to talk to somebody that really understands water. Feel free to call in customer service, talk to our water quality technical services group. Great folks there, and they'll get you answers and try to support our customers. So.
Every now and then, there'll be an opportunity to just get the water tested from your own house. I'll see an advertisement about that. Is that worth doing?
From where? Testing from where?
Say from Aqua.
Generally, our test results are available in our consumer confidence reports. And you can call in also to the Water Quality Technical Services. We often get the question of, what's the hardness in this area? I need to set my water softener. Or I got one earlier today that I thought was unique. My washing machine. I need the hardness for my washing machine, my dishwasher. Okay. But as far as testing goes, once again, the ideal from my perspective is that you shouldn't need to do the testing. You should be able to call in and get the support to have any questions answered. We will often, for example, with the Act 120 program and lead service line replacements and other things like that, we will often offer to the customers for testing for lead and copper to make sure everything's going well during that process. But once again, it's another opportunity to call in and ask your question and see if we can help.
So Dave, how would somebody find that phone number for technical services? Is there a search term in Google, for example?
I mean, it depends on your question. You can call into our general customer service number. I don't have it on. It's on the website.
Yep.
And that should guide you. They'll be able to route you based on what your question is and where you're at to where you need to be. And then they can maybe get you to somebody more specialized if that's what your question is pertaining to.
See what color my head is.
That's right. Yes. Check your service. You can search by address. It's very easy. So thank you. Appreciate it.
Thank you.